The last example in section 1.6 for foundations for geometry. It's an application problem. I don't really care which method you use. If you would like to solve this using the distance formula or the Pythagorean theorem, I am good either way. Your book only shows one way, but I know that there's two. So let's take a look at this. They've given us a baseball diamond, and they're showing us 4 bases on the baseball field, and it actually does form a perfect square. It would be weird if you were running from first to second and that was longer than you running from second to third, or third to home, so it does need to be a perfect square. The bases on a typical field are 90 feet apart from each other, and they want to know if a player throws the ball, if the catcher throws the ball at home plate, he's at home plate, he throws it to second base, and it's like right on, like perfect path where he's standing on home plate throwing to second base and actually throws it to that base, to a person on that base. What's the length of that throw? I don't care which way you do it. They've given you the coordinates for each of the points, so you could use the distance formula to find how far apart they are. You could do that and go, okay, well, I'm going to do, let's start with the x's. I got to subtract my x's, so 90 minus 0 is 90. Got to square that. Now do the y's. 90 minus 0, also 90. And you got to square the 90, which will give you 8100 for each of them. So 8100 plus 8100, and then you got to add the 8100s together. You'll get 16,200, and then they want you to round to the nearest tenth. So I need my squiggles there, and that's going to give me approximately 127.3 feet, because that's the base paths are 90 feet apart. So you could solve it that way, no problem with that. You could have done the Pythagorean theorem, and you're like, no, I see a right triangle. I'm going to, the distance of each of the legs are 90, okay, because they said that home to first and first to second, second to third, third to home they're all 90, it's a square. And I need to find the hypotenuse, which would be the segment that connects home to second base. And so then you could do 8100 plus 8100. See how it's so similar? Like the numbers are almost exact. They are exact. We're just doing it kind of a little bit different way to get to it. And we're going to get the same exact answer. So again, I showed you 2 ways to do it, and I certainly do not have an expectation of one way over another. It's your personal choice. So I'm going to leave this last one for you to try. We're going to do some different information. The center of the pitching mound has coordinates of 42.8, 42.8. When a pitcher throws the ball from the center of the mound to home plate, what's the distance of the throw to the nearest tenth? So really, you are concentrating on this part of the triangle here, okay? They gave you the coordinates of this midpoint as being the center of the mound as 42.8 and 42.8. So, I don't know, I think you can figure that out. I think you could easily use the distance formula to find that distance. You may want to try the Pythagorean theorem and verify it with the Pythagorean theorem and just take a risk and see if they both work. All right, thanks for listening.